Hello everyone and welcome back to our videos in Bazara Aviation Academy. Today our video will be about turbine engine and this is the third class. Before we start our lesson, I will answer the last homework. The last homework was what's the meaning of compressor stool? The compressor stool is the imbalance between the velocity of the inlet and the compressor rotational speed. Also, the compressor stool can happen because the using of a thrust reverser at low ground speed. Before we start our class, I hope by the end of this video, all the students can able to understand the meaning of the afterburner and what is the location of the afterburner and how to use the afterburner, and can understand the meaning of the thrust reverser and the location of the thrust reverser and the benefit of the thrust reverser, and can understand the meaning of the accessory section and the location of the accessory section, and can understand the engine station numbering, also can understand how to reduce noise of the engine and the meaning of or how to make engine mount, and the last one was the meaning of the EBU and the location of the EBU and the using of the EBU. Afterburner is a component of turbine engine, but not all the classification of turbine engine. Why? Because the afterburner you can find it in turbofan or turbojet engine just. But you will say why he didn't mention that in the component of turbine engine. I didn't mention it because the afterburner is optional component. You can find it in some engines and in many engines you can't find it. Why? Because afterburner is used on the military aircraft just. Why they use it in the military aircraft? They use it for increase the thrust of the aircraft. Here, when we see here, we have a turbojet engine. In this turbojet engine, we have the inlet, compressor, combustion, turbine, and here is the location of our afterburner. So, the location of the afterburner is in the end of the turbine and forward of the exhaust section. It has a flame holder, ignition source, and a source of fuel. Here is the afterburner, and now where we mention here is the flame holder. This our flame holder. And here we have the torch igniter. This torch igniter consists of source of ignition and fuel nozzle, and we will explain it now. Here we have the torch igniter, and this for the source of ignition, and here the fuel nozzle, and we will see that now. This our fuel nozzle, it will connected to the torch igniter. Here we have our source ignition, like our spark plug, and they will connect it together on our torch. We will see here, we will connect the fuel nozzle, and now we will connect the spark plug. This is our fuel nozzle, and here the spark plug, and as we see here, this is the fuel nozzle and this is the spark plug. Here we will see the location of them on the aircraft. This our location of spark plug, and this the location for our fuel nozzle, and here we will say the manifold for the fuel. They will spray fuel from here like this. From here we will make spray for our fuel. And after spraying of fuel we will say like this. Here we have spraying for the fuel from the manifold, and now we will make burning or burning for fuel after it's burning itself. And this primary ignition, and here we have secondary ignition and burning, and this used on the military aircraft for give us more thrust. Thrust reverser used on transport aircraft that use turbofan or turbojet engine. They use the thrust reverser for providing braking and directional control during normal operation or normal landing. Also used for providing braking and directional control during emergency landing. And the last one used for backing an aircraft out of the parking. The maximum reverse thrust capability is always less than the forward thrust capability. Operating with thrust reverser at low ground speed can cause compressor stall due to re-ingestion of the hot gases. It can also cause ingestion of a fine sand. Here we have our thrust reverser, and we will see how the thrust reverser tool works. When we see here, the door will open and will prevent the gases from go outside. They will back for the forward, and this the operation of our thrust reverser. We have three types of thrust reversal system, and they are: the first one we called clamshell doors, as we see here. This called clamshell doors. And the second one we have is called bucket doors, as we see here. This the second type, and here we will see how it works. And the last system we have, it called blocker doors, and these are blocker doors and used in turbofan engine. Here we have the runway, and here we have the aircraft will approach on the runway, and it will use the thrust reverser. We have two safe gradients are built into selection of reverser thrust. The first one, thrust reverser cannot be activated until the aircraft has the weight on the main wheels. And the second one we have is, here we have our throttle, and here we have the control of the thrust reverser. Here our thrust reverser control, and here we have the control throttle control. And here we say thrust reverser cannot be selected until the throttle lever at the idle point. Accessory section. The accessory section is located in the underside of turbine engine and is a combine of gears. That gears used for supply movement or kinetic energy to some parts of the engine. If we back together to the airframe book to ETA 29 or ETA 28, and we say in the hydraulic system we have a component. One of this component is the engine-driven pump. The engine-driven pump, how it can work? It can work when the engine starts. So it connected to the something called gearbox. So the gearbox will give kinetic energy to move our pump in the hydraulic system. Also can give movement or kinetic energy to our engine-driven pump in fuel system. Also can give us an electrical system or can drive our generator. As we see here, we have two gearbox, the high speed gearbox and low speed gearbox, and it has gears that combine together for give us a movement, and this type of gear called pivot gears, if you remember it in the general. And here the high speed gearbox is connected to the high compressor N2, and the low speed gearbox is connected to the low compressor N1. The high speed gearbox is used for engine for a specific accessories such as a starter motor, oil pump or fuel pump. The low speed gearbox used for drive accessories that not require engine operation such as hydraulic pump or alternator. Some engines has one compressor. So how we can reduce the speed of the compressor? Because of the turbine operate at high speed with engines that have one spool of compressor, the accessories at the appropriate speed it need to something called reduction gears, or we can see it intermediate or transfer gearbox that use for reduce the amount or the high speed of the compressor to make it at low speed. Engine station numbering, providing a technician with a quick and accurate way to locate a certain area during maintenance, and this made for make the maintenance for a technician easier. For example, here we have the inlet duct and it will be the area number 1, and here we have the low compressor, the area number 2, and this the area number 3 is the high pressure compressor. Focus here, if we have 3 stages of a compressor, number 4 it will be a compressor, also a station for compressor. But here in this engine we have 2 stations of compressor, N1 and N2 just. After that the compensator or the burner number 4. After that the high pressure turbine and the low pressure turbine. And if we have 3 stages of compressor in the turbine we will have 3 stages, but here we have 2 stages of compressor, so we will have 2 stages of turbine. After that the tail pipe it will be number 7 and the exhaust nozzle number 8. Station numbering, establish the location for taking pressure and temperature reading. For example, ABR readings. The ABR readings is taking from the engine inlet, and the engine inlet is station BT2, which means pressure total at station 2. Similarly, the turbine discharge pressure is taking at station BT7. Here we have the tail pipe, the end of the turbine, and it called pressure total number 7 tailpipe or turbine discharge. So the reading of the ABR, it comes from the difference between the BT7 and BT2. EBU, it means auxiliary power unit. The auxiliary power unit is a small turbine engine that locates on the tail of the aircraft. Why they make a turbine engine in the tail of the aircraft? For supply electrical power and bleed air for ground operation. Why? For make cooling, heating, lighting and engine starting. That means when the aircraft on the ground, the EBU, it will run for give electrical power like lighting for the aircraft, or for give bleed air for the air conditioning system for make hot or cold air. Also it used for give bleed air to the engine for starting the engine. The EBU drive electrical generator and supply compressor bleed air for make anti-icing, heating, cooling. That means the EBU is connected to a generator. That generator gives us electrical power and connected to compressor, and this compressor gives us a bleed air. The EBU started using on starter generator, motors and aircraft battery, fuel supply from the main aircraft fuel tanks. The EBU can start by using a motor, its own motor, and the power that's come to the motor, it comes from the battery of the aircraft. What about the fuel? The fuel comes from the tanks or the main tanks of the aircraft. At the end of our section, we will know how to reduce noise of turbine engine, especially turbojet engine. We can do this on ground by the first way we use this, and this called turbojet deflector, or as we mentioned in our book, it called blast fences. This used for reduce the noise of engine on the ground. And the second way we use this way, and this called hash. This hash used on the older turbojet aircraft and used for reduce the noise of our turbojet. Now at these days newer engines use a variety of techniques to reduce harmful noise. For example, some turbofan engines blend fan discharge air with the exhaust gases to reduce sound emission.